Welcome to Leco Academy. Now, in this video, we are going to tackle a question in chemistry under more concept. Here the statement says 2.4 grams of magnesium ribbon was reacted with 100 cubic centimeter of 2 molar. So this one here, the M represents molarity. So this is the concentration. 2 molar dilute sulfuric acid. So this is the concentration of dilute sulfuric acid which reacted with magnesium ribbon. What is the volume of the gas produced at room temperature and pressure? RTP, this one, it stands for room temperature and pressure. Now, how can we calculate the volume of the gas produced? So to know the volume of the gas produced, we need to come up with the balanced chemical equation. So to come up with the balanced chemical equation, so magnesium is reacting with sulfuric acid. So magnesium reacting with sulfuric acid. So when magnesium is reacting with sulfuric acid, this one, it must give us magnesium sulfate. So this is giving us magnesium sulfate plus hydrogen gas. So this is the gas that has been produced. Now, if we check our chemical equation, so this chemical equation here, it is balanced because we have one more of magnesium even there. So hydrogen, we have 2, also at the product side we have 2. So our chemical equation is balanced. Now, after balancing the chemical equation, we then include the state symbols. Magnesium, this is solid. Sulfuric acid, this is aqueous. Also magnesium sulfate, this is aqueous. Hydrogen, this is a gas. Now after coming up with the chemical equation, we need to find the limiting reactant or the limiting reagent so that we know which one determines the amount of hydrogen gas is going to be produced there. Now, to find the limiting reagent between the two, we need to find the number of moles. So number of moles of magnesium. So in the statement here, we've been given the mass of magnesium. So the formula that we can use to find the number of moles, this is mass over the molar mass. Since we've been given the mass of magnesium. So the mass of magnesium, this is 2.4 grams. The molar mass, now for the molar mass, you get the relative atomic mass of magnesium. So the relative atomic mass for magnesium on the periodic table, that is 24 grams per mole. So this 24 into 2.4, this one, it is going to give us 0.1. So this is the number of moles of magnesium. So moles of magnesium, this is equal to 0.1 mole. Now, as for sulfuric acid, so if we check for sulfuric acid, we've been given the volume and also the concentration. So the formula that we are going to use to find the number of moles, so for sulfuric acid, number of moles is equal to the concentration multiplied by the volume. Also the volume must be in cubic decimeter. Now, if we check the volume that has been given, so this volume here, this is in cubic centimeter. Now, to convert this one to cubic decimeter, we are going to divide 100 divided by 1000. So this 1000 into 100, this is going to be 0.1 cubic decimeter. So this is our volume in cubic decimeter. Now, to proceed with our formula here, the concentration, this is 2. So 2 multiplied by our volume, this is 0.1. So 2 multiplied by 0.1, this one it is going to give us 0.2 more. So the number of moles of sulfuric acid, this is 0.2 more. So for sulfuric acid, we have 0.2 more. So this is the number of moles of sulfuric acid. Now, if we compare the two, the one having a smaller number, that is magnesium. So magnesium is having 0.1 and sulfuric acid, this is 0.2. So 0.2 is greater than 0.1. So magnesium is the limiting reactant or the limiting reagent. So magnesium, this is the one determining the amount of hydrogen gas that is going to be produced. So this equation tells us that 1 mole of magnesium is equal to 1 mole of hydrogen gas when we compare mole to mole. So if 1 mole of magnesium is equal to 1 mole of hydrogen gas, meaning if magnesium, this tells us that if magnesium is equal to 0.1 mole, also hydrogen gas is equal to 0.1 mole. Since magnesium is the limiting reagent or limiting reactant, so this magnesium, it is the one that determines the amount of hydrogen that is going to be produced. So to calculate for the volume at room temperature and pressure, we need to know that 1 mole of gas at room temperature and pressure, 1 mole of gas at room temperature and pressure is equal to 24 cubic decimeter. So if we have 0.1 mole, volume therefore is equal to 0.1 mole multiplied by this one here, 24 cubic decimeter. So 0.1 mole multiplied by 24 cubic decimeter, this is going to give us 2.4 cubic decimeter. So this is the volume of the gas that has been produced, which is the hydrogen. So this is how we calculate the volume of the gas. You have to come up with the balanced chemical equation. So you then determine which is the limiting reagent. So to determine which is the limiting reagent between the two, you have to find the number of moles. And here we had 0.1 and 0.2 for sulfuric acid and for magnesium. So the one having the less value, it is the one that determines the amount of gas that is going to be produced. And here, the one with the less value, it is 0.1, which is the magnesium. So the magnesium, it is the one determining the amount of hydrogen gas that is going to be produced. Now here we said 1 mole of gas is equivalent to 24 cubic decimeter. So to know the volume that is in 0.1 mole, we multiply by this value here, giving us 2.4.